area and ventilate it. Get the air out.
So is it a tear in the visceral flora?
It would depend on what happened as the damage. Would the damage be to the thoracic wall? Would the damage be to the lung itself? It would depend upon the damage itself and whatever's allowing air into that cavity. So that pleural fluid that would be existing, like I keep saying, acts as a lubricant. In cases where children are born with respiratory distress, it's usually because this fluid is not present, and they can simply go in, give them a shot into that area, and basically give it fluid, and the children are usually okay. Now, other times, respiratory disorders are totally different, but in the case where those lungs are struggling, that's usually what can happen. So respiratory therapists are called in, that sort of thing. Now, when we call or say the term mediastinum, because that's something you will hear, this is a central region that has contents of my thoracic cavity, but not the lungs. What do you think's right here? The heart. Remember, you can always look at it and see where it looks like this little notch that's present, and that's for the heart. So we end up with like a cavity inside of a cavity with the lungs. And that structure works very well for us. So the goal, ventilate, move air. That's the goal. So we're going to talk about our pulmonary ventilation. All right? Because remember, we have to get air to the blood, then we have to get from the blood to the tissues, then we have to go from the tissues back to the blood, and then from the blood back to the lungs. Okay? And then, of course, cellular respiration is its own little process that's occurring within a cell itself. All right? Yeah, they call it respiration because of the use of oxygen, production of CO2, all that sort of fun stuff. When we say or hear the term respiratory cycle, this would be one inhale, one exhale. In that process, there are certain activities that should occur, and there should be certain pressures that should be present, and we should move a certain amount of air. All right? And based upon your physical condition, your age, all these different factors, there will always be a norm value. Okay? Doesn't mean that that value is across the board, because other factors come into play. Okay? So whether it's a child, whether it's a teenager, whether it's an adult, whether it's elder, whether they have a physical, do you see where I'm going with that? Numbers will vary. So numbers that will be shown in your textbook, they are based on a healthy male in their 20s. All right? So that is a norm that they're looking at for the textbook. So we usually say that we can have quiet ventilation, forced ventilation. These are actual terms that you will hear in the medical field. The movement of air is dependent on a lot of factors. We're going to find, like I said earlier, we have external pressures, we have internal pressures, We have nerve stimulation. We have physical. There are so many things. We have our respiratory center in the brain. There are so many things that will affect our actual breathing that you'll probably never think about your breathing the same again. But hopefully in my class, everything we talked about, you don't think about the same ever again. That's my goal, okay? I want y'all to think about things differently. Now, when they refer to the muscles of respiration, they are referring to our diaphragm and intercostal muscles. But wait a minute. Aren't those muscles innervated? So therefore, I got to deal with my nervous system coming into play. All right, so I'm going to have some type of control over this breathing. Like I said, we can't let this tissue inflate or deflate based upon no type of restrictions being present. So, breathing. How many of y'all pay attention to it? I do.
It depends on what you're doing.
I mean, it's like slightest little difference, I pick up on it in my breathing. It's so funny. Same thing with my heart rate. But anyway, I guess because I teach it so much. So now, remember, this is a homeostatic control. It is definitely, you know, we definitely need to breathe for life, okay? We can only survive without air for a very short amount of time, all right? I mean, as a kid growing up and everything, you know how you would have like hold your breath contests, okay? All right, wow, those days, okay? People would be like, oh man, I can hold my breath for a minute. But then what happens, okay? You're gonna breathe. You got little kids running around throwing their little temper tantrums. One of the things they do is hold their breath. Let them hold it. They're gonna pass out and start breathing again, okay? So just be like, don't even play. And so, you know, you have these controls that come into play because it is a life function and therefore getting controlled by the primitive regions of our brain. You guys remember the brainstem? All right. So we're going to be dependent on repeating something. The repetitive stimulation. In other words, breathing in, I can do to a certain point, but then it's going to be like, okay, you got to let that go. And that will occur to a certain point. All right? So we have what's called a reverberating circuit. Okay? The neurons that are going to control this, it's a cycle. And it's termed reverberating. So, inhale, exhale, inhale, and they don't stop. They're running 24/7. And y'all know the rest of it, 365, 366, sleep.
I'm sorry, can you repeat that one more time?
They're reverberating. It's a reverberating circuit. It's one of the very few, probably the only type of, well, no, some other. So it's one of the few ways that the nervous system works on a reverberating circuit. Our spinal muscles that help us keep us upright work on a reverberating circuit. But what we're going to see this information, yes, very high in the net. So we're talking at the level of C1 and C2 for this nerve connection. That's why people who suffer the severance of the spinal cord at that level tend to pass away. They tend to die. You can survive a severing of the spinal cord at C3 and lower better than you can at C1 and C2. There are people who have. I'm pretty sure none of you all are familiar with the original Superman.
Yeah.
Y'all are? Oh, okay. He actually survived decapitation. His spinal cord severed at C1, but he survived. But he was on ventilation for the rest of his life because that circuit no longer worked, to give you an example. Okay? Most people who have an accident at that level of their spinal cord are not going to survive. Skeletal muscles, if you remember, they are innervated, and therefore they receive a nerve impulse. Because we're on a reverberating circuit, we're picking up that impulse to contract and relax, inhale and exhale. Okay? So, to do this effectively, there's a lot of coordination that's occurring. The centers that exist in this area of the brain. Now, note their terms, okay? VRG, DRG, PRG. If I come over here, and if I look at this structure, I have a dorsal respiratory group. Dorsal, to the front or to the back? To the back. Note its location. It's to the dorsal side of the brain stem. I have my ventral respiratory group. Everybody agree to the front, okay? But then, what about P? P stands for pontine. Everybody remember the pons, okay? So, I have these three groups that are going to work to make sure that I get to inhale and exhale based upon this circuit that got created. Anything that disrupts that circuit will result in difficult breathing or none at all, so to speak. So, note my ventral group, the primary generator. So the ventral group is the one creating this inhale and exhale. My dorsal group, does my breathing need to be faster, slower, shallow, or deep? A lot of my external sources affect this. For example, Mile High City, Denver. Let's go to Denver. Any y'all been there? Mile High, for a reason. Anybody know why?
I might be wrong. This might be the wrong place, but isn't it? Is that the city where it's like the cold air is trapped? Like it does something.
It does.
It's trapped like.
Based on the
pressure.
It's based on the fact of where it's situated with the Rocky Mountains around it, but it's turned mile high because of the. Okay, so here's the thing. All right, in Virginia, Senator